these two used to be the same person, but that's not the point. The point is here we have a marble launching machine, so Harry can just put it in. There we go. There's a spring in there. Here's a hole. See, and then he pushes it down, and then jams the card in. There we go.
Jamone.
Well
You get it?
Jamone, that's correct. And we're gonna roll it down here, and it's gonna knock the card out this little ring thingo. Unfortunately, the ball does not jump through the ring. That would be too Jamone for this experiment, but it goes up, like just boom. And it hits this, no, it doesn't hit the ruler, but we can measure how high it goes on the ruler, and then measure if velocity is real or not. So Xander will be here recording with this phone in slow-mo. And whenever you're ready, Ginger. And boom, bang, perfect. Jamone and this is our physics experiment. Okay, so in that video, the ramp was elevated by 1 centimeter. So after repeating that 3 times for reliability, we raised it by 1 centimeter, so now it's 2 centimeters, and this increased the velocity. So we kept doing this, raising it by increments of 1 centimeter until it reached 10 centimeters high. So the aim of the experiment was to test the effect of this increased velocity on the maximum height reached by the marble and the airtime. So to measure the maximum height, we had it next to a 1 meter ruler, like this, and then we just obviously saw how high it went. And to measure the airtime, we saw how much time it took to leave Mr. Marble Launcher and reach its maximum height, times 2, because that's easier than doing the whole thing.
Traveler, boy! Hello there!
Yo, so the aim of our experiment is to determine the effect of the velocity of the cart on the height and hang time of the ball being launched from the cart. So we hypothesize that an increased velocity will increase both the height and hang time.
Yeah. So now to talk about our materials. Our first material was the books we used. These books were used to prop up our ramp, and so that way we could create the necessary velocity for our cart. Here we go, let's have a look at this ramp. So we propped this up in intervals, and that would give us the necessary heights to test out our experiments. We also had our cart, which would be propped up on the ramp and released on time to make this work. Another one of our materials was our retort stand, which would sit towards the bottom of the ramp with the retort ring out. And the final piece, the marble launcher, would be attached to the cart, with the card sticking out. The card sticking out would hit the retort ring at speed and knock the marble out of the marble launcher, which would create the necessary data needed for our experiment. And also, a ruler and a slow motion camera to record our results and figure out how our experiment worked.
Hello there!
Hello there. So for our risk assessment, we concluded there were 3 main risks. The first main risk was stepping on a dynamics cart or marble and falling over, similar to this one. So the main thing we did to counter that was by alerting people to the experiment and putting the experiment in the corner so no one would need to go anywhere near there. Our next major risk was swallowing the marble. We countered this by making sure there were no toddlers in the area and kept idiocy to a minimum. The third main risk was getting hit in a sensitive part of the body, like the eye, by a marble. And so this was countered by getting people to wear safety goggles and alerting people to the experiments they weren't anywhere near when the marble was being fired. Okay, so time for a variable analysis. The 4 main variables we controlled were making sure we used the same launching mechanism, same marble, same ramp, and made sure the cart started on the same position on the ramp. Our independent variable was the height of the ramp, and our dependent variables were the maximum height of the marble and the air time.
Here are the tables of our experiment. If you want to see them, pause now.
Time to do some calcul. So to find the maximum height reached by the marble every time, we'll be using Formula 3. Now, by analysing the video, we found that the initial velocity of the marble being launched was 4 meters per second. So, subbing all the values into Formula 3, the final velocity, which was 0 as it was stationary at the top, 0 squared equals 4 squared plus 2, and acceleration due to gravity is 9.8 meters per second squared. So as it's moving downwards and we're calculating the upwards vertical velocity, this will be negative 9.8. So here we have just some algebra, and then s equals 16 on 9.6, which equals, and we'll round that to 0.82 meters, equals 82 centimeters. So the maximum height reached by the marble should have been 82 centimeters every time. So, time to do some more calcul. If you look down here, we're using Formula 1 to find the airtime. So, this is the time it takes to reach the maximum height. Remember, v is 0, acceleration, negative 9.8, t is the unknown, and the initial velocity was 4. So more algebra, and we find that t equals 4 divided by 9.8. And we do it on this calculator, we get 0.41. So it should have taken 0.41 seconds to reach the maximum height, times 2, remember, and that equals 0.82 seconds. Time spent from when it leaves the pipe, reaches the maximum height, and goes back down to the pipe level.
Trend in the height of the marble was that it plateaus at around 4 centimeters ramp height. This differed from our thesis, and we suspect that the reason for this could be due to the launching mechanism. Until it reaches 4 centimeters ramp height, the cart is pushed out upon impact and the height increases. However, beyond this, it's knocked out fast enough that we believe it makes no difference on the resulting height. The hang time went along with our thesis as it gradually increased with increasing initial velocities. We figured this would occur as, due to inertia, the ball should continue travelling forwards when leaving the car despite the upwards force of the marble.
Execute Order 66. Let's do some vector calculations. So, by analysing the videos, we managed to calculate the horizontal vector, and the vertical vector from before is 4 meters per second. So using Pythagoras' theorem, we found x, which is 4.06, and this, because tan theta equals opposite over adjacent, theta equals inverse tan 4 over 2.2 on 9, which is 87 degrees. But we want to find this angle, so it's just 90 minus 87, and that's 3 degrees. So the magnitude of the vector was 4.06 meters per second, and the direction of the vector was north 3 degrees east. So we did this for all of the different ones. That last calculation was when the ramp was 1 centimeter high, and this is all the others, so pause if you want to see them now.
Hello there.
So, even though we changed the direction of our vectors and the overall magnitude was affected, our upwards velocity always stayed the same.
This means the maximum height and the airtime of the marble shouldn't have been affected, only the distance travelled. So uncivilized. Dunk!
Although our launching mechanism wasn't consistent, we repeated the experiment 3 times for reliability. Our experiment was valid as we have addressed the aim and all the variables were controlled.
So obviously our experiment wasn't perfect to start, no matter how good we are. We did have to make a few changes. So our original launching mechanism, the knocker out of the card, was going to involve an Arduino board, an ultrasonic sensor, and like some motor. If it sounds too complicated, it is, and that's why we had to decide to use a more mechanical way of knocking it out. And the second one we had to do was our marble launcher. So initially, the notch we cut for the card to be in was very low, so when it fired, since the spring was compressed more, it shot the marble a lot higher than 1 meter, which is cool, but you know, taping 2 1-meter rulers next to each other isn't cool, so we had to cut another notch a bit higher up and reduce the power.
Thank you. An improvement to the experiment we could have made would be to use a better launching mechanism. In our experiment, the mechanism we used was a bit inconsistent at times and wasn't always giving us the results we'd hoped for. So an improvement could have been to use, for example, an air cannon that launched a ping pong ball up into the air.
Just tell me when to stop.
Okay, thank you. We also could have measured our results better through the use of sensors and other technology. You can stop. My favorite.
We achieved our aim of discovering the effect of the initial velocity of the cart
On the maximum height and the airtime of a marble launched from the cart.
We correctly hypothesized that the airtime of the marble would increase with an increasing initial velocity.
However, we're incorrect in saying that max height would increase as it plateaued after a certain point.